Okay, let me go over the calendar for this week. First up is I have your quizzes graded. I put them in a grade book, and I'll try to hand them back either tomorrow or Thursday, but most of you guys did very well. I think the only thing that I saw was just some students had where if you find the inverse, you guys are good about finding the determinant, just adjusting your matrices inside your 2x2, adjusting the elements inside your 2x2 matrices, swapping the A and D value, and then changing the signs of B and C. Some of you guys kind of had that little, either forgot to do that or had the order a little bit incorrect, but for the most part, I didn't see a lot of big issues. Maybe just copying down the wrong sign or multiplying incorrectly, but those are relatively minor. You guys did as a whole did really well. So we're going to continue with talking about inverses, but now we're going to be moving towards using that to solve systems of equations. We have algebraic ways of working through it, but we're also going to kind of see how matrices can use to solve those types of equations as well. I think we'll be able to kind of get a little bit ahead. We're dealing with 3x3 matrices, but we're also going to be able to learn how to use a calculator to find inverse of a 3x3. It's too much to do without a calculator, so we're going to learn how to do it with a calculator. My hope is that we can get ahead so that we can get to word problems a little bit earlier. I think the more time we can have working with the word problems, the more comfortable we're going to feel. So I don't think these topics will give you any issues. It's the word problems we have to kind of spend more time on. So I think we can, as long as we're comfortable, we should be able to reach applications and word problems by Thursday. We'll have Thursday, Friday, Monday to do word problems. We can go over the quiz later this week or Monday. Review Tuesday, and then next Wednesday will be a matrices test. Okay, if you guys can turn to page 13. Okay, so ways to solve systems of equations. Okay, so here are the algebraic ways to solving systems of equations. One is the elimination method. Second is substitution method. And third is the graphing method. Okay, we're really just going to be working with elimination or reviewing elimination method. So when we go through this process, what does this solve for us? The solution represents the point of intersection of these functions. Okay, these are going to be straight. These are going to be linear graphs. So the majority of your answers will just be one solution. So imagine two graphs just intersecting. If they have two lines, they're only going to, if they intersect, they're only going to intersect at one point, right? That's the majority. Okay. There's also possible to have no solution. That means the two lines are what? They're parallel, right? If they're parallel, they're never going to intersect. Okay. And then the other possibility is there's infinite solutions. And that's when you have a line that is overlapping another line. It's basically the same line. So if I have two equations that are essentially the same lines, they're going to meet at every point, right? So that would be considered infinite solutions. Okay, so let's review using elimination method, and then we'll talk about a new way of solving involving matrices. Okay, so we're going to start off with elimination method. Okay. First thing we do is we want to make sure that our x's and y's and constants are all lined up. And they are. Negative 4x plus 9y equals 6. X minus 3y equals negative 6. Elimination method means that we want to be able to add the columns in a way where either the x's go zeros out or the y's zeros out. We can, doesn't matter which one we choose, as long as we get one of them to go away, we can solve for the other variable. So we could target the y's, we could target the x's, but just so that we can just work on the same process, let's try to eliminate the x's. So I'm going to rewrite the top. So what can I multiply the second equation by to get the x's to be opposites? 4, okay. So if I multiply a 4 through the second equation, let's just copy down the first one. Okay, so we're strategically trying to get one of the variables to go away. We're able to get the x's to go away, right? Negative 4x plus 4x equals 0, so that goes away. Now let's add the other columns. Nice. It was negative 12y plus 9y. Equals. Okay, so the advantage of doing this elimination method, trying to eliminate one variable, is that we can use this to solve the other variable. Because initially, if we just use either equation, we'll be stuck not being able to solve for the other variable, right? We'll get one in terms of the other, but we're not able to solve. But here, we're able to get the x's to zero out. If I can solve for one variable first, then I can circle back around and solve the other variable. So I'm going to solve for y, divide both sides by negative 3. Y equals what? Y equals 5. I'm going to go back to either of my original equations. Looks like the second one seems easier to plug in. So I'm just going to insert the 5 in for y of the original equation. Doesn't matter which one. They'll both produce me the same x value. Okay. Replace 5 in for y. Add 15 to both sides. So we have one solution, right? So that means these two lines will intersect at one point, and that one point has the ordered pair of 9, 5. Okay, so let's review, right? Any questions there? Elimination method? Yes.
I got another.
Okay, what'd you get?
I got X is 6 and Y.
Okay, how'd you get that?
Solve for X first.
Okay. Did you get?
Solve for X first. So I multiplied the bottom one.
Okay.
I got negative X. Oh.
Right, -9, right? X -9. X is 9, yeah. Okay, so now we have a new way to solve. We're going to be able to use matrices to help us solve this equation, and we should arrive at the same answer. So matrices will have to take on the form of AX equals B, okay, where A is the coefficient matrix, X is the variable matrix, and B is the constant matrix. So this is how we're going to, go back to the original equation, the system equation that we already solved, and now we're going to represent it using matrices. Okay, so what we're going to do is you're going to take these numbers, these coefficients, and you're going to create a coefficient matrix. So let's hope you see how that's going to look. So we're basically going to separate the coefficient from the variables. We have variables X and Y. And then the 9 and -6. Okay, so look at your systems of equations. Look at the matrices that's created. Do you guys see the connection, and do you see how they are being built? Okay. Any questions so far? So I'm just going to name this here. This is my coefficient matrix. This is my variable matrix. And then my constant matrix is on the other side, B. So what we want to do is we want to get this variable matrix by itself. So to do that, we're going to have to move the matrix A over to the other side. But when you move matrices, you're not going to divide. Okay, the way you move it is you're going to make it the inverse. The inverse will allow this matrix A to basically shift to the other side. So the way so when you move this matrix A, and as it turns into its inverse, make sure that you put it in front of matrix B, okay? If you put it after, it's not going to quite work out, okay? So anytime you're moving a matrix to the other side in order to get another matrix by itself, it's going to turn into its inverse, and it's going to come first, okay? So let me show you what the notation we're going to use here. I'm going to say matrix XY is equal to the inverse of this matrix. I'm basically moving this matrix over to the other side. I haven't found the inverse yet, but I'm just going to indicate that I am going to find the inverse with that -1. Now, that -1 doesn't mean I'm going to raise this to a -1 power. This is simply an inverse notation. So we're going to spend the time to find the inverse of this 2x2 matrix, just like how we did on the quiz. But once we find the inverse matrix, we'll multiply these together using our multiplication skills, and we should arrive at the same answer that we arrived using the elimination method. Okay, so again, look at where we started. Look at the matrices equation that we built, and look at how we're moving that A to the right side. Is everybody good so far? Okay, so now the majority of our work is going to be trying to build the true inverse of this 2x2 matrix. Okay. So we first have to find the determinant, right? So let's do that. Okay, what's the determinant of this matrix A here? 12 minus 9. Okay, so let's do the inverse here. I'm going to use as much room as I want here. And know that 1 over to the determinant goes out in front. And we got to go through our adjustments inside our 2x2 matrix, right? What happens to the A and D values? Swap places. And then the 1 and 9 transforms to a different sign. Okay, now that we've created the true inverse, we can drop the notation. That's just to indicate that we haven't done the process yet, but now we've finished the process. This is now the inverse matrix, and let's put the resulting B on the other side here. So we're going to multiply this out, and when we multiply this out, we're going to be able to get X and Y, and they should match the answer that we got because it's the same problem. Okay, here's my suggestion. My suggestion is wait until the end to worry about that 1/3. Now, you could multiply that 1/3 through this 2 by 2 matrix and then do multiplication. But I think the issue with that, it's not wrong. The issue with that is you're having to deal with fractions in the middle of your problem, right? If I can wait until the end to involve the fraction, then it's just make things a little bit easier for me to deal with the multiplication process, right? The less we can deal, I mean, if we can avoid fractions, let's just go ahead and avoid fractions, especially if we don't need it until the very end. So let's just go ahead and worry about this 2 by 2 and 2 by 1 matrix, get that resulting 2 by 1 matrix to form, and at the very end, we can multiply by 1/3, okay? Again, it's not wrong if you don't do that, but I think it's the easier path to wait to deal with the fraction. Okay, so we know a 2 by 2 matrix and a 2 by 1 matrix will be able to form because the inside dimensions match. We know we're going to end up with a 2 by 1 matrix. Okay, so I'm going to set up my multiplication process here. Okay, I'm going to move my rows from left to right. I'll move my columns from top to bottom. I'm going to pair up each term as I move from element to element. Okay, so -3 times 9, and then -9 times -6. Okay, second row, first column, -1 times 9, -4 times -6. Okay, we get 54 minus 27, which is 27. -9 plus 24, 15. Okay, so I have the 2 by 2 matrix and 2 by 1 matrix resolved. I can replace this whole thing with 27 and 15, and then I should resolve that coefficient in front. Multiply the 1/3 through every element. 27 divided by 3 is 9. 15 divided by 3, 15 times 1/3 is 5. Okay, we match the elements here. X is equal to 9, Y equals 5. All right, same results as using algebraic elimination method. Okay, any questions about the process? Okay, so next page, we're just going to practice these procedures, right? Set up our matrix equation, move the 2 by 2 matrix to the other side using inverse, go through the full inverse process, multiply, and then resolve the coefficient in front. Okay, so let's go through these problems on the next page, page 14. Okay, so work alongside me as you go through your steps, and you can check the board as you're trying to match your steps. And for now, if you can show every step along the way, right? So when you move that 2x2 matrix, just go ahead and move it and just do the inverse notation. And once you get that inverse notation showing, then you can go through the full process of getting it to be a true inverse. Any questions? Make sure that you're doing the full procedure of your inverse process, right? That you're swapping the A and D value, and that you're changing your B and C signs.
Is it always going to be the... Oh, wait, never mind. I have to do that.
Okay. Now, once you're here, my suggestion is ignore the 1/14. Do the 2x2, a 2x1 multiplication. That way you can avoid the fraction until the very end. Otherwise, if you multiply the 1/14 through, you're dealing with fractions and it's just messier to work with. Right? So get that 2x2 and 2x1 matrix to multiply out. And then at the very end, you can distribute that 1/14 through. X equals 4, y equals -2. All right, try number 3. Mhm. Yeah. Okay, what did you guys find for number 2? Sorry, number 3. Anything stand out about number 3? Determinant is 0, which means that inverse doesn't exist, which means there's no solution. Right? We can't go through this process. Because if you get a determinant equals 0, that means you're dividing by, you're putting that determinant in the denominator. 1 over 0 doesn't work. So as soon as you see a 0 for your determinant, you know you can't go through this inverse process. There's no solution for this equation.
Top of the page that it either has no solutions or infinitely many.
Mhm.
We know.
I think for us right now, we don't have to worry about which variation we're dealing with. Hold on, let me see here. So infinitely many solutions, in the sense this kind of falls under that no solution, in the sense that we're not able to pinpoint a specific value. So for now, let's just call it no solution, and if we need to change it, I'll circle back to it. Okay. But for now, we know it's definitely not going to be just one solution. We're not able to move forward. We'll say for now it's just no solution. Okay. Yeah, go ahead. Okay, try number 4. Go through your setup. We have the determinant. Make sure you adjust your 2 by 2 matrix. Swap your elements, change your signs. Wait to the very end to work in the -1/57. Just focus your attention on the 2x2 and 2x1 matrix. Okay, rather large number here, 342 and 0. Yes. Yes. I want to show you the calculator methods tomorrow, but today we're just going to practice without a calculator. Okay. So eventually we're going to be able to do it by hand and by calculator and use both to kind of double check each other's work. Okay, page 15. Now, page 15, we're going to just do elimination methods. So we're going to use algebra methods. So does anybody still need this page? So on page 15, we're going to try to line everything up. We want the x's together, the y's together, and the constants together as well. So we may have to add and subtract some terms to get those columns to line up. Okay, so we'll do matrices on page 16, but page 15, we're just going to go through elimination method. But let's just do number 1 and 2 on page 15, and then when we do page 16, we'll do all 4 problems using matrices inverse method. Okay, anybody still need this page? Okay, so let's try going through elimination method. Here, I want the x's and y's on the same side and the constant on the other side. So I'll move that 3y over to the left. I'll move the 4x to the left and put it first. Okay. Any questions so far? Okay. We want one of the variables to go away. There's multiple ways to do this. I'm just going to target the x's. I mean, you could target the y's and be fine. I'm sorry, I'm going to target the y's. Just numbers seem a little bit smaller. But if I want to target the y's, I also need these signs to be opposite. So if I multiply the top one by 2, then the bottom one I have to multiply by what? Good, -3. That means I want one to be 6 and the other one to be -6. Now you could also target one to be 20 and the other one to be -20. That's fine as well, but just so that for now, let's just line up our steps and you can decide on your own if you want to try a different problem. Okay. Distribute the 2 and -3 through. We should get the y's to cancel each other out when we add. Y's goes away just like what we wanted. And then just add the remaining columns. Once I have one of the variables solved, I'm going to go back to one of my original equations. You can feel free to use the one that you rearranged, but I like to use the original one just in case I made a mistake here. I can catch myself, right? So it doesn't matter which one. I'm going to say I want to choose the second one here. Any questions with elimination method? Okay, try number 2 with elimination method. And then we'll be done with this page and we'll just go to the back page and practice the rest with inverse matrix. Okay, try number 2. Oh, sorry, I didn't copy it right. Thank you. -2, -7. I put it incorrect here, but I just didn't put that -2 there. Yeah, -2, -7. Thank you. Guys, when we get to the next page, we're just going to do 5 and 6, okay? So that'll be our classwork. Finish 2 and 5 and 6, yes. Okay. So when you get done with 2, we're just going to do 5 and 6. And I'll just come around and check you guys off for 5 and 6 on that. Yeah, I'll plug into one of the original ones, yeah.
Okay, thank you.
But actually, you can plug into either one. It's fine. I just like the original ones because in case you if you made a mistake, add
Yeah.
subtracting, it's a good way to double check with the original.
Okay, thank you.
Page 16, number 5 and 6, you're going to do matrix method. Okay, don't use elimination method for 5 and 6. Go back to using matrix. Yeah, just 5 and 6. right, check the board for number 5. Okay, any questions with 5? Again, wait to deal with that 1/27, right? Don't work in that 1/27 until the end. Okay, finish up with number 6. Yeah, optional we use after this show you what to do.
Okay.
In a few minutes, I'm going to check your pages 13 through 16, just the ones that we did together.
It was Spanish class. I knew I had another class with you, but I couldn't remember. Yeah. She was nice. I liked her. Yeah, I remember Brody at the school. What? You don't know this? I didn't tell you the story? What happened? So we were in Spanish class, right? And we were doing this activity. And we were supposed to like get like clothes and try to